Alright, this week we're going to start our 3D lessons, getting away from 2D, but still kind of keeping things in mind. I'm going to go ahead and open up my Microstation. And don't have my disk, but let me see if I can find something here that we can work with. You'll probably be starting with your projects. Here's a seed file. We'll start with this one. You can use your regular seed file. I'll just check this one out and see what it is. I'm going to do a file, save as, and we're going to call it put it in my document so I don't forget it. We'll call it 3D primitives. This will just be a practice exercise to get you introduced to 3D modeling. We'll kind of delete whatever we've got in here. And I got this old title block, a little different than what we've used in the past. We won't be needing it anyway, but we'll leave it there. So right now, if you notice at the top of the screen, it says that it's a 2D model, 2D V8 DGN. So what we'll do is create a new model. And you'll notice over here on the left, the tools we have are drawings, drawing composition, terrain modeling, and some main menu. We're going to go to our models tool. We're going to create a new model, and this time it's going to be a design file 3D, and we're just going to call it primitives. Hit OK. And now you'll notice up here at the top it says 3D V8 DGN. And if we look at this, we've got more tools now. We've got solids modeling, surface modeling, mesh modeling, terrain modeling. Well, we had terrain before. Feature modeling, visualization, animation. We still have the drawing composition. So we'll kind of work out of this solids model, and you notice that this tool still has a smart line feature, arcs, still has the shapes tool, but down here under E we have primitives. So we won't create any particular levels for this because again it's just practice. I'll put this in line weight 2 so you can see it a little bit better. And we'll start with our first primitive. This is a solid slab. Now when we start doing this, you'll notice if I just let me go check, and I'm going to see what I have for working units here. We're working in inches. So let's say I want a slab that's 2 inches by 4 inches by 1 inch tall. If I just left click on the screen, you'll notice I get my normal view oriented compass. Now keep these letters in mind, and I use an acronym I forgot the acronym now, but we use F for front, T for top, S for side, I know it is soft V, SFT, and I put the O in there just because that's our origin key, remember. So SOFT, think of the word soft, and then V for view rotation. So if I hit the letter T, oops, I got to be in a smart line tool here, oops, right there, we go. Oops, hit the right letter. There we go. Oh, I know why, because I'm in the top view. You'll notice up here, I apologize, been a long weekend. We're in a top view up here. So what I want to do, we top, front, right, isometric, bottom, back, left, and right isometric. We're going to go into an isometric view. Sorry about that. So now, if I hit T for top, you'll notice my compass rotates to a top. F for front, or S for side. So we can see all of our views, SOFT, O for origin, and then if I hit V, it goes back to a view. So think soft V, if you can't remember the letters. We're going to start with T, and we said this would be a 4 inch long, 2 inch deep, and you'll notice the compass turns all by itself 1 inch tall. Let's try another one over here. This will be 2 by 2 by 2. Okay. Again, we can do it by front, side, or top. Let's do this one by the side. We're going to key in 2, left click. We're going to go vertical, 2. Now watch what happens when I left click. My compass will automatically rotate to a front view, and I can key in 2 in this direction. Okay? That's all there is to a slab. Let's change our color. Use something else, and we don't really pay much attention to our 5 colors for line weights in 3D modeling because we kind of export that out differently anyway. Let's talk about a sphere, or actually we'll do this next one. And one thing to remember is look down in the bottom corner for your instructions. If we were back in this create slab, it says enter start point, left click, it says define a length, define a width, which in this case is tall, and then define a height. So all of those are instructions on the bottom. So if we look at this next one, which is a pyramid solid, it says enter a center point. Okay, and I'm going to hit T for top. It says define a base radius, and we can say, you notice it's inscribed or circumscribed. I'll go with the circumscribed because I can pull it out, and I want a base here that's 1 inch, so it's 2 inch just like a radius, so it would be 2 inch in overall. It says define a height. Let's go 2 inches, and then define another width. Let's put in 0.25. So we can create a pyramid. And keep in mind also, we're using the same move, copy, rotate, scale that we do in 2D. So if I wanted to move this point to here, it's just as easy as moving it over. And now when we look at this, we've actually got it located right on top of our object. So we'll go back to a isometric. Anytime you want to look at it in different views, you can hit your rotate view and just rotate it around. Now, and also this, you'll notice this compass comes up. I can move my pivot point wherever I want. So now when I hit my rotate tool, it rotates off that point. If I want to move that, you notice when I move my cursor close to it, it becomes darker. I can just left click and I'll move it. This might be my pivot point. So now it's moving off that front corner. As we're doing these, sometimes it's kind of fun to change the rendering. What you're seeing here is a wireframe. It's faster on the computer, but we can also look at it as an illustration, and we can say, let's look at it as a modeling illustration. And this tool here will let us turn on some default lighting so we can kind of see how shadows might fall on it. We'll play around with lighting more later on. So it's a pretty neat tool to work with. Now the next tool we have, and I'll change my color and we'll try to do this while it's in the rendered mode, is a sphere, just a ball, and it's by center point. So if I want to set this ball right on top of this pyramid, let's use our offset points, and I'm going to say left and right mouse button to do a tentative snap, hit O, and I'm going to go over to enter, find the center point. I didn't really want to do that. O, hit enter, find the center point. I'm going to hit O again and hit F. I'm going to go up 1. So I'm 1 up from the top of that. So if I left click and come back down 1, I'll just key in the number 1. It places that sphere directly on the top of that little piece. So using that offset in 3D with the SOFT tools is pretty easy to deal with. You can see how it updates our shadows also. If we take a look now at our next shape, which is a cylinder, and we'll change our color to something else. I'll go with this dark yellow. And let's say I want a tentative snap here, hit O. I'm going to come out here 2 inches. I'm going to hit T for top, so it's setting on the bottom. We'll put in 1 for a radius, and we'll put a length of 4. And I can also, if we went back to our circle, well, we'll do some other stuff with this later. So we had a pyramid here. Now we can do, and that pyramid gives 4 edges. We could also change that, just going back, I've never used this, but try 6 edges. So we can put in a hex head shape. We'll key in 1, pull it up, and see if I can change it on the fly. Nah, won't let me, sorry. That was stupid anyway. But just to show you how you can make that work. So it gives you this cone. Now these are solids. These aren't surface models. These are, and just like file management. When I think about file management, not to get off the subject, but when I think about file management, I actually think about these as physical file folders. Just like you would have a file cabinet in your office or your home or your place of business, think about the same thing on the computer. When I'm drawing these models, these 3D models, I'm thinking about them in terms of actual solid pieces. They could be wood, they could be granite, they could be concrete, they could be steel, any of those things. Don't think of them as just computer animation pieces. Think of them as actual solids. And it's much easier to find your way around. So let's go back to our cone tool. Let me change the color to something, I'll go with this funky fuchsia. AccuDraw points is how we're going to draw this. So if I just left click and I'll put in 2 for a radius, we'll put in 3 for a height, and we'll put, you could leave it at just a point if you wanted to, or you can put in, we'll say 0.2. And remember, see how I'm also using an AccuDraw compass to put it in AccuDraw. So I'll put in 0.25. It gives me that radius on the top. Okay, so there's a cone. Slab, pyramid, sphere, cylinder, cone. This next one is an elliptical cone solid. If I grab this one and look down at the bottom, it says inner base elliptical center point. Let's be colorful and put it in blue. And we'll put in a primary radius of, let's say 1.5. A secondary radius of 0.5. Define a height. A top primary radius of 1. And a secondary radius of 0.25. So we can see now with this, if I use my rotate tool, how we're getting these multiple shapes. And we don't actually have to be in an isometric view to draw these. I can kind of draw them from any perspective that we want. The next shape that we have is an ellipsoid. So again, we're going to follow the directions on the bottom. We'll change to another color. And I'm just going to put a point. The center point says define primary radius, which is going to be, let's say, 2. Secondary radius, which is going to be 0.5. And a tertiary radius, which will be, let's say, 2. So we actually end up with something that looks like a disc. If you start thinking about all the shapes in the world that we could possibly use, it's pretty, just using primitives, we can come up with some fairly unique objects. The next primitive we have is a torus, basically a donut. It says enter start point. Let me change my color again. Enter start point. Bing. Says define a center point, which is, I'll move it to 2. And says define an angle, which in this case we want to go 360 degrees. And a secondary radius, which would be 1.5. And there you have a torus. So it's center point of the actual tube itself, center point of the object, and then a secondary radius to give you the radius of the tubular shape. And we're just doing primitives. We also have extrusions and all kinds of things that we can work with and play around with. The next one in the list of primitives is a wedge solid, just basically a piece of pie. And we'll come over here. It says define a center point, define a radius. I'll come out here 3. It says you want to define the wedge here now. So we'll define the wedge angle at let's try 60 degrees, and then we can put in a height of 1. So there's another primitive shape. And the final one we have is a polyhedron. We can put the number of facets on here. Let's try, let's be funky and try whoops, guess polyhedron's got to be an even number, so we'll do an 8-sided polyhedron. You can go by vertex, edges. If we try vertex, it says enter center point. And as I pull this out, we're going to end up with this diamond shape. I'll pull it out like 0.5. Now let's try a 20-sided polyhedron. And let's see, can we do it? Yes, those are the only numbers we have for polyhedron. But again, you probably won't use this much, but it's always there if you need it. Now, these are all primitives. We've gone through that. And modifying primitives utilizes things that are all part of Boolean operations. If I want to, for instance, make all of this shape that we created here one particular object, we can use under this T menu, we have unite solids, find the intersection of solids, or subtract solids, or find the difference between solids. Let's take unite solids, and I want to find the union of this shape and this shape. You'll notice it all turns green because it turns to whatever the first element I select. And then if we want it to be red, I can say find the union, hopefully this is touching enough, between this and this, and you'll notice everything turns red. So this is all one, whoops, guess it wasn't down far enough. What we'll do is move it down, because it's just touching, there's nothing actually to hit it. We'll move it down 0.25 inches. And now we'll do the Boolean operation, say find the union of this and this. And now when we go to move this object, it all goes at once. Let's just make a copy of that particular shape, move it over here, and see what else we can do with this. If I knew this is like 2 inches by 2 inches by 2 inches, which is what I drew it at, we can put a fillet on the edges. Fillet is just a rounding of the edge. So let's take our fillet tool, and we're going to put a, let's do a 0.5 fillet. And we'll select this edge, and I'll hold down the control key and select that edge, and just left click. And see how that rounds that edge off? We can rotate it, do the same thing to this edge, and this edge, and right where, well, let's do all 4. This edge, hold down the control key, and this edge, this one, and this one. Whoops. Kind of a mathematical impossibility there. Let's see if this does the same thing. There we go. So now, if we rotate this around, we can see what we have. Let's take it a step further. Sometimes we like to see what the limits of this are. Let's put a 0.25 radius on here and see if I can grab that edge right there. And that kind of rolls it the other way. Let's try 0.1. Still does it. No, I guess it actually does what I asked it to do. I thought it was rolling the other way, but you can see, let's try it, see if I can get this edge. Very nice. Sometimes the view that you're looking at just doesn't look like it. So you can see one more edge here, I think. This one. So see how that smooths that out? If we actually look at this, we're looking at right now as an illustration. If we look at it as smooth with shadows, we see that we get a much more smooth looking operation. And we can even do more with the edges. Let's put a 1 inch radius. Whether it did or not. Copy this over. Sometimes these are mathematical impossibilities, so 0.5. There we go. You can see how that difference between this edge and this edge, how that rounded that piece off. Now the other thing that we can do with Boolean operations, and I'm going to put this back in a illustration mode because it shows up a little bit brighter with the shadows on it. Let's say I needed to draw or put a hole through this solid right here. One of the easiest ways to do that would be to take my circle tool. I'll find the bottom, hit O, and I'll hit S for side. See how I moved that to the side? And I'll just move it up, let's say 1 inch. And I'm just going to draw a circle. You'll notice that circle's in green. We'll go out 0.25. So what we have is a two-dimensional circle on top of this that's actually parallel with the surface. This other Boolean operation is also in the T menu. It says cut solids by curves. If I left click on this one, it's going to cut in both directions, which is fine because I don't really care. It's going to cut all the way through the object. I could define a depth if I wanted to say just cut it 1 inch deep, but in this case I want to cut it all the way through. And I don't want to split it, and I don't need to keep the profile. So I'm just going to left click on my object, left click on my circle, and you see how those arrows are pointing and saying whatever I find in this object in either direction, I'm going to wipe out. And I can just left click now, left click again, and when we rotate this piece, we're able to see all the way through. And again, we can fillet the edges. We'll put a 0.2 fillet. That's in inches. Just grab the edge of the circle, and you can see how that pops into place, the fillet. So all of a sudden, from these very, very, very primitive objects, we can start building some fairly complex pieces of geometry. So what we'll be doing in our exercises, and we'll play around with this a little bit more in class, but as far as applying materials, just to give you a little hint on materials, I can say settings, rendering, materials, and if I want, I'll say palette, open, and we'll grab some, let's see, how about some marble or granite. And if I double click this, we can actually see the objects over here. In this case, we'll go with this granite Java Pearl. And I'm just going to apply this to one object. I'm going to assign it to this piece right here. The whole thing then will become this pearl color. And because it's kind of a large color, I can change this pattern. So this is in meters, and let's just change our size. And this is actually changing the size of the pattern itself. Whoops, grabbed the wrong one, sorry. Granite Java Pearls, okay. Grab this, and I'll change it to 0.1. Oh, it doesn't want to let me. Some reason. Oh, there it goes. So you see, by changing that scale to 0.1, let's try 0.05. It becomes even smaller and finer. If I keep that, you'll notice that I can also change the bump map. Bump map takes the light and dark colors and actually gives it a texture. So if I pull this way up, and we'll close this out, we can see it looks pretty cool. Let's actually take this now and just go into a Luxology rendering. This is just an example, and we'll hit the, that's just something else I was working on. It says default lighting is on, but what we can see now with this rendering mode is it's actually going to give us a more precise rendering of this object. Even though we haven't played around with the light that much, we've just made some adjustments to the material, got default lighting turned on. We can see how realistic now this piece is becoming with the rendering as part of the package. So in our next class, we're going to play around with this this rendering and Boolean operations. You can see, I don't know whether I can zoom in on that. You can see how nice that texture is on the actual granite that we put on the material. I close this out now and come back in. I'm just going to change this back to a, well, it's already on illustration. We'll do a fit view. And the other thing we can do is a chamfer. A chamfer is similar to a fillet, except it's straight edges. So we look at this square here, and the first edge, distance 1 could be 0.5 inches, and distance 2 could be 1 inch. So if I grab this edge right here and click it, what it's going to do is take, actually it was locked, so let's try that again, 0.5 and 1. We'll try it over here. So what that did is it cut 0.5 off one side and 1 inch off the other. So we can do a chamfer, just filleting the edge of different objects. And whether I can do it on a circle. Yep. So it'll actually cone these things off. So again, a multitude of things you can do with all these different types of algebraic items here that allows us to cut, modify, edit, Boolean operations to find unions and differences. If I were to take, well, that's all one. Well, let's try this. If I were to take this cone and put it right down here into, find a snap point, rotate it to a top view. What I want to do is kind of center that right in there. The enter key works just like it does in 2D. Bring it up to a front view, and we'll pull this down. I'm not sure what this is going to create, but we go to our isometric now and say I want to take the difference, and I don't want to keep any of the originals, between this shape and this cone. You'll see what it does is it gives me this kind of hollowed out section of tube that gives me a pretty spectacular looking object that has these cuts in it. So doing something mechanical is pretty easy. And we'll talk about being able to save these as cells, and just we'll probably start out by creating some kind of mechanical piece, then we'll move into some furniture and then some architectural work, and be able to take these 3D objects and export views like the top view, the front view, the right side view, to a two-dimensional drawing that we can still print out on paper. We can still put the dimensions on, and that's something that we'll talk about on Wednesday's class. So for now, it's just an introduction to getting used to using the compass in a 3D environment. S, O, F, T, and V. Just to review, there's our V, there's our T for top, side, and front. Keep that in mind, because a lot of times you're going to see this compass and you're going to raise your hand and say, something's not working, I can only move in this direction. And I'm just going to say, hit your S key, or hit your F key, or hit your T key, because 9 times out of 10, it's your compass is just not in the right orientation for what you want to draw. And again, V brings it back to the view. Okay? And I will expand on this further on Wednesday. Thanks.